Hi everyone, I'm going to explain to you how to complete assignment 1 of Unit 12. So I'm going to go to share. But this is the assignment. Okay, and you got some reference material here where you can get information from. It's due in on the 27th. So let's go down to task 1. Produce a written report to explain the safety procedures and maintenance requirements for both hydraulic and pneumatic powered systems. Include end diagrams when necessary. The task should not be more than an A4 page in length. So produce a written report to explain the safety procedures and maintenance requirements for both hydraulic and pneumatic powered systems. Well, if you go back into Teams, you go to class notebook. You go to the subject area, I should say. Content library. Unit 12. Should have done this before. Now, here on I've created something called an assignment tab. On here, I've created information for assignment 1. So assignment 1 help. There's your assignment, and there's the which you can download a copy of, and there's some assistance. So you can get information regarding safety, like safety, hydraulic safety, safety considerations. Some of that question can be answered within these two files here. Now, also you used to do research online regarding safety, hydraulics and pneumatics, and type in the keywords according to what the assignment asks you to do. But it's just basic stuff on how you would check them for maintenance, what the maintenance procedures are, what the safety procedures are, if anything went wrong, and it's just basic regulations, rules and regulations. Also in this PowerPoint that we've been using quite often, this PowerPoint on, I think it's slide 7, it goes through some health and safety regulations which you can use. So you can use this PowerPoint, you can use these two files as well. So it shouldn't be too difficult to answer that question, but you'll have to do some research on the internet as well. Okay, now let's go to task 2. Task 2, what we have here, we have quite a simple circuit here. Some of you might be aware of this circuit, some of you will not. I missed one of the lessons with the groups where I could explain this in more detail. Now what you have here, you have a single acting single acting piston at spring return. So when pneumatic air, or when air energy goes into here, it expands the cylinder, and then as soon as you cut off the air supply, the pneumatic air supply here, it returns back to its original position here. You've got here a roller valve number 1.3. So when the actuator extends, the tip of it touches a roller valve, which is a switch with a ball at the end. When that switch presses, which is switch number 1.3, this is 1.3 here. It looks similar to this. That therefore actuates this input valve here, and then it allows the actuator to go back to its original position, because this controls this part of the circuit controls the extension. This controls the retraction. So when it extends, it touches 1.3, then it controls the retraction. So the cylinder, as you can see, the air, when it goes into this pilot here, it will switch from this position to this position, and it will switch into this first position, and therefore it will go back to its original position here, and then the air in here will be exhausted through here. Okay, so what happens is when you press the foot pedal, you press the push button, the AND gate, the AND logic, when it's high in both sides, it switches this control valve here from the first position to the second position. Air goes into here, and it allows the cylinder to extend. When the cylinder extends and touches 1.3, which is a switch you'd place at the top of here, it's like a limit switch. 1.3 is being pressed, the first position will switch on to the second position, air will go into here, and therefore it will switch this control cylinder back to its original position, and this will extend back because air will be exhausted through here eventually. That's what would happen. Okay, and So that's the control. You're asked to explain the operation of the circuit, which is basically what I've done. That's your compressor, which is your air supply. This is the pedal switch, an input device. This is the push button. So two buttons connected to an AND gate. So when they're both high, and then this control valve switches from the first position to the second position, allowing it to extend. These two devices, the speed control devices, I've talked about this in class a bit, but they control the speed going out and going in. So these are your flow control valves, and this is how they're labeled. Now, how do you label these? This is 1.2, 1.4, 1.6. This is 1.1 because it's a control valve controlling this. This is 1.0. This is obviously going to be 1.3. This one here. And then you've got this here. This is called a timer. It's one individual component. It's a unit or a component. Anything in a dotted box means it's one component. It's a component that contains several components. In this case, it's a timer. So if this is 1.3, this is going to be 1.5. So when the actuator extends out, it touches 1.3, and after a period of so many seconds, air is allowed to go from here to here, allowing it to extend back. So it does not extend back immediately, only after the timer has been set. We're going to learn how to deal with this a lot more in lesson times. Okay. And the hydraulic pressure is to extend a load based upon the diagram below. How much pressure is in bars is required in the system. Now there's a formula that says pressure equals force divided by newtons. So it's force. I should say force divided by area. So it's force divided by the area, which is 100 centimeters squared, will get you the pressure. Now, because we need to work in meters where possible, so convert the centimeters to meters squared, and just divide it by 100. So this is going to be 1 meter squared. And then whatever answer you get, it's going to be your pressure answer. Now, you've got to convert that to bars. 1 bars equals 100,000 newtons per meter squared. So when you've got your newtons per meter squared value from your pressure, you just divide it by 100,000 to get your bar, because that's on the pressure gauges. Normally we read bars or we read PSIs. So that shouldn't be too much of a problem here. Okay, name the component, spring return, push switch, a spring return lever, your AND gate, your 3-2 control valve, your 3-2 roller valve, spring returned, timer, and these are your what you called your flow control valves. You've got 2 here for controlling both directions. And this is your double acting spring return cylinder, and that's going to be the roller 1.3, 1.4. This is the roller connection here. This is the an input device, so it's a switch. It's called a roller switch, or sometimes called a lever input. Either way is correct, doesn't matter. Okay, and that's 1.1. And then you've got here a simple circuit, which is simpler than your other circuit. It's a double acting cylinder. It's got flow control going in and coming out, and this is actually a meter out system, which we're done in class. So only the exhausts will be controlled, and then this is a 5-2 valve controlling the direction of the double acting cylinder. This is your roller input controlling retraction. This is a roller in. This is controlling extension, and this is your a lever. It's a lever valve. This one here. Okay. So you've got here. You've got to physically, mechanically, with your hand, you've got to press this. It will start the circuit. It will allow air to go from here into here. Now it's in the. These are your 2 roller positions, A0 and A1. So you've got 2 rollers, one connected to here when the cylinder is in the closed position, and one connected to there when the cylinder is in the open position. So when it's closed, that gets activated, air goes in. When it's opened, the A1 gets activated, and air then it allows it to retract. So the idea, as long as this is open, as long as a shutter this is pressed, and therefore this is open here, what will happen? This cylinder will keep going back and forth each time, left and right, left and right. Okay, it's all it does. the roller valve in. These are your faults. These are possible faults. That to find the answers to these, sometimes you can use common sense, or what you can do to help you. If I go back into Teams, there's a PowerPoint. This one here, that answers that question for you. In fact, you'll see that circuit in that PowerPoint. If you go through halfway in the PowerPoint, it actually gives you them specific examples and how to counteract them specific examples. You just need to read this PowerPoint. You'll come across everything in that PowerPoint, how to answer that question. These won't be a problem because they're all inside that PowerPoint. And then you've got to explain the operation of the circuit, and you've got to draw a supply system circuit for both hydraulic and pneumatic systems. That's again inside. Sorry, it's inside. What am I doing? It's inside this PowerPoint here. We did it. I think it's the first of the lesson, or the first or the second lesson we started in the year. But more information can be obtained from research, and you've got to explain the health and safety aspects of work of each part of the power unit for hydraulic and pneumatics. Where am I now? God, I don't know where I am now. I'm confused. Okay, I'm here now. So that's how to answer this question here. Redraw the circuit, which would only allow the cylinder to retract if a push button is pressed and the roller valve A1 is activated. So you put an AND gate here, and then you'd have a roller and you'd have an AND gate here. So similar setup to what you have here. Okay, this part of the circuit, you'll just copy here, but it'll be roller and a push switch. Okay, so similar setup to what that is there, and you should be able to answer all the questions accordingly. Okay, so that should complete your assignment for you. Now, so all the stuff is actually in Teams. You just got to do some research, maybe it's research on the internet as well. Okay, that should help you answer the questions. So I'm going to end the video from now. Okay, have a good day.